Hi guys, in this video we're going to talk about how to do or how to solve a system of equations, a 3x3 system of equations using substitution. That is, we're going to have 3 equations and 3 variables. Let's get started. So here we want to find a solution of this system, right? We're looking for the location or the point where all of these 3 lines intersect. So we're always going to start with the easiest or the smallest of the 3 equations. Right, so if I can see here, the smallest one's going to be the one in the bottom. It's the one that has the least amount of variables, and that's the one that's going to lead us with the least amount of work. So let's begin. I'm going to do negative 3z equals 9, and I'm going to solve for z. So we're going to divide by negative 3 since we are, let me clean this up a little bit. Since we're multiplying negative 3 times z, right, the inverse operation is to divide by negative 3. And that leaves us with z equals negative 3. We have one of the parts of our solution. Remember, we're looking for 3 of them. I'm going to go ahead and scratch this off since we've already done it. And then the next step is I'm going to move up and solve the one that has the next least amount of variables in the equation. And that's going to be the one that has the 2 variables. I'm going to do this in a different colors to not confuse you with all the handwriting that's going to happen here on the screen. So I look at the second equation, and I have y plus 2z equals 4. But now since I have the value of z, I'm going to substitute that into my second equation. I'm going to use the value of the previous answer, use it into the second equation to find the value of the next answer, the next variable that I'm looking for. So this equation is really this. It's y plus 2 times z, which is negative 3, equals 4. And then I solve. I have 2 times negative 3 gives you negative 6, so I have y minus 6 equals 4. I add 6 to both sides, so I can get rid of the 6, and I can leave y by itself. And I'm left with y equals 10. There it is. I have my second answer. Remember, because this is a 3x3, I am looking for 3 variables, 3 different equations, 3 different parts of this answer that I'm looking for. So now the only variable that is missing is the letter x. So I've used both equations, and now on the last step, I'm going to use the last equation that I have not used yet at the very, very top, and I'm going to use that one to solve for the missing variable x. Now I'm going to take the z value and the y value, and I'm going to plug them into the location here and where they belong in this last equation. So on the last equation I have 2x minus y, which is 10, plus 5z, which is 5 times negative 3, and that equals 24. My handwriting here is a little off, so I'm going to improve that number as a 2. Okay, so now that I only have one variable in this last final equation, right, now I can solve for the letter x. I'm going to start by simplifying these numbers a little bit and doing some multiplication. So I have 2x minus 10 minus 15, because 5 times negative 3 is negative 15, and that should equal to 24. I'm able to combine like terms here. The 10 and the negative 15 combine to negative 25. So I have 2x minus 25 equals 24. When I solve for x, I'm going to move the 25 over, so I'm going to add 25 to both sides. And I have 2x equals 49. Now at the very end, lastly, I have 2 times x, so to leave x by itself, I'm going to divide both sides by 2. And I have x equals 49 divided by 2, or 24.5. when I was preparing this problem, I thought that was going to come out as a whole number. So I did not do this on purpose, but we have three values. We have the x, y, and z, and since we're looking for the location where they all intersect, we're going to write it as a x, comma, y, comma, z. We have 24.5, comma 10, comma negative 3. That is the solution, the x, y, z. So, a quick recap. You want to start with the one that has the least amount of variables, right? Find the one that has the smallest, easiest equation, solve that one first, use that answer, and plug it into the next smallest equation so you can find the next variable. Once you have two variables, you're going to use the most complicated, longest equation, take the two values and plug them in for x and y, or y and z, or whatever variables you found, and then lastly find the last variable. Once you have all three variables, you'll be able to write it as x, y, z, or in alphabetical order if it's a, b, c, or whatever letters you're given. All right, let's move on to the next one. Here in this last problem, we are asked, is this point 1, 3, negative 2 a solution to the following 3 by 3 system of equations? Right, so is this the answer for this system? One thing you could do is you can solve the system and find out if it's the actual answer, or you can work backwards, and I want to show you how to do that. To work backwards, we first have to go into the assumption, right, that these variables, that these numbers represents the x, the y, and the z. It's always going to be in alphabetical order. So I can assume that 1 is the x, 3 is the y, and negative 2 is the z. And we're going to use these values, like the 1, we're going to plug them in everywhere we see an x. The 3, we're going to plug it in everywhere we see the y. And the negative 2, we're going to plug it in everywhere we see the z. And then we're going to simplify and see if the answers check out. Now, I'm going to do this 3 different times. I'm going to start by numbering these equations. I'm going to number this as equation 1. I'm going to number the second one as equation 2. And the last one as equation 3. It doesn't matter what order you go in, just as long as you check all 3 equations, that those points exist and that they work in that equation, it should be good to go. Let's start with the first equation. So we have x minus y plus z equals negative 4. So instead of x, y, and z, we're going to substitute the values of x, y, and z. So we have 1 minus y plus z, which is negative 2. And that equals negative 4. Okay, here I'm going to be careful with my negative values, right? I'm going to simplify. I have 1 minus 3 minus 2 equals negative 4. As I combine like terms, I have 1 minus 3 is negative 2 minus 2. And then negative 2 minus 2 is in fact negative 4 equals negative 4. So since the left-hand side of the equation equals the right-hand side of the equation, we have ourselves a solution in this one right here. Now we got to check the other two to see if they also work. Now, this whole thing right here could be done in the calculator, right? So you can avoid this whole step. If you want to plug this whole thing in the graphing calculator, not graphing, but more like a calculator, it'll tell you if it equals negative 4. So as long as you write this step and this step to show that it's correct, that's the amount of work that's required, really. The next equation is equation number 2, as I'm going to do now 2 times x, which is 1, minus 3 times y, plus 4z. And that equals negative 15. Again, the left-hand side has to equal negative 15. So I'm going to start multiplying things. 2 times 1 is 2. Negative 3 times 3 is negative 9. 4 times negative 2 is negative 8. And I just want to find out if the left-hand side equals negative 15. 2 minus 9 is negative 7. Minus 8. Negative 7 minus 8 is in fact negative 15. The second equation also works. So far, these two lines are intersecting in the exact same point. Now we need to find out if the last one intersects as well. So I'm going to check the last one, and I'm going to plug this third equation in color blue. So I have 5x. X is equal to 1, so I'm going to put 1 for x, plus y, which is 3, minus 2z, which is negative 2, equals 12. 5 times 1 is 5. 3 stays the same. Negative 2 times negative 2 is positive 4. 5 plus 3 is 8. And if you have already noticed, 8 plus 4 is equal to 12. So here we have a scenario where all three equations work for this particular point. So what does that mean? It means that, let's say we have some sort of graph, and I have this line, equation 1. Let's say we have equation 2. And then we also have equation 3. And everything intersects at that point that we spoke about. 1, 3, negative 2. Because all three equations work, right? They all equal to the number that we expected them to equal, then all of the three equations are true or consistent at this particular location in space. It's hard to draw this graph three-dimensional, right? So just imagine a three-dimensional graph with three equations intersecting at the same space. Okay, so if you have a multiple choice question and it's telling you A, B, C, and D, which one of these is a solution, one thing that you could do is plug the numbers back and solve and see if it actually equals the solution. All right, guys, well, I hope this has helped. These videos that I'm making online are supposed to help an adjacent or support the material that we're doing in class, right? So if at any point you are needing more help or more, if you want to pause the video, you want to write it down, you want to take additional notes, sometimes all you need is more exposure to material. At first it can be overwhelming, it can seem like a lot of work, right? But the more you see it, the more you work on these problems. If you're doing the ones in the class and then if you're doing the ones here on my YouTube channel, you're going to start seeing that you're going to be more comfortable with this new thing that you're learning. And that's kind of a big tip for the whole year, right? The more you do something, the more comfortable you become with something that is new. All right, guys. I hope you guys are doing great and that this video has helped. Make sure you leave a comment if you like me to make some more videos like this. And just hit smash the like button. Talk to you later.